Good afternoon, everyone. Welcome to InfosecTrain webinar series 2, blockchain and technical primer. Uh, Sorry for the delay. We were expecting some more candidates, so that's why we were having a small delay for the 10 minutes. So we would like to start the webinar. I would like to introduce myself, Suraj Kumar. I would like to introduce Mr. Rakesh Sharma, who is our lead for blockchains. So who will be taking care of the whole webinar. I would like to introduce him for carrying forward.
Thank you, Suraj. Can you hear me well?
Yep, well and clear.
Okay, great. So excellent. Thank you for finding time to attend this webinar. My name is Rakesh Sharma, and I'm a security consultant working with a financial institution in Singapore. And I bring along experience of working in several cybersecurity domains for over 10 years. I have worked with companies like Symantec, McAfee, Blue Coat, Qualys, etc. And I am also a blockchain enthusiast who want to, deep dive into fintech, which is a revolutionizing technology based on blockchain. So this webinar is intended towards information technology leaders, engineers, and business analysts, and the blockchain enthusiasts or students who want to make a career in fintech or blockchain. So I would request you to mute your microphones so that we don't get any noise during the webinar. And you can hold on to your questions that you may have till the end of this webinar, where we will have a separate Q&A session, and I would be happy to answer your questions. So this webinar is a technical introduction of blockchain concepts, where we will make use of the Bitcoin blockchain. But this webinar does not deep dive into Bitcoin as a cryptocurrency, the mining concepts, how the miners are buying several equipments, and how the trading of cryptocurrencies or alternative currencies are happening in the market right now. So we'll be focusing more on the blockchain concept itself. So let's deep dive in. So the agenda for this webinar would include the history of blockchain, how it happened, and people started to realize that this amazing technology can be put to use in the different domains, how distributed ledger technology came into existence, and how the blockchain actually works. What is the mechanics or the machinery behind blockchain, how the blocks are created and how transactions are created, and what are the different types of attacks that can be conducted against blockchain infrastructure. And finally, the use cases and applications where now blockchain is currently being used into or experimented in. So let's start with the historical background. So to understand the blockchain technology, because it's a game-changing technology, it is useful to understand the history which led to this and how it became a buzzword rapidly. From Bitcoin to blockchain to distributed ledgers, the cryptocurrency space is fast evolving to a point where we cannot identify in which direction it is headed to. But we are not without clues. While many of us know that innovations in this space are very new, they're built on decades of work that led to this point. So by tracing the history, we can understand the motivations behind the movement that spawned blockchain and share its vision for the future. So we'll discuss about these historical instances or milestones that occurred in the blockchain space. Cyberpunk is a group of people where these people want to use cryptography to fight things like government surveillance, social and political injustice. So before the 1970s, cryptography was primarily practiced in secret by military or spy agencies. But then a mailing list was created by a group of people known as cypherpunks. So those people were activists advocating the use of cryptography and privacy enhancing technologies as a route to social and political change. And then there were some issues with the traditional banking systems as well, where banks were the central controlling authority. They knew how the money will flow. They had a complete control over the money flow from one country to another, or one bank to another, or to the customer. So in traditional banking systems, there were some issues like banks were a central point of failure. So if something happens wrong within the banking infrastructure, it will cripple the whole banking system. Banks also had a monopoly in such a way that they were able to increase their transaction fees at any point of time, depending upon the market fluctuations. And these banking systems were also not available to everybody. So only those who go to banks and sign up for the new accounts might be able to maintain minimum balance, or the banks will have their own interest charges which they can afford, were connected. So to remove this traditional banking system, a decentralized banking system has now evolved, which has evolved because of the blockchain concept itself. In 2008, this financial meltdown occurred, and Lehman Brothers and other banking financial institutions declared bankruptcy, and they were at the brink of erasing of their existence. So Lehman's collapse was a big event that greatly intensified the 2008 economic slowdown and continued to the erosion of the 10 trillion market capitalization from the global economy. So it was identified that if banks are the main central controlling authority, and if they fail, then the whole banking system will collapse, or the economy will collapse. There was one issue in the traditional banking system which was called as double spending. So double spending is a problem that is very common in digital currencies. Now we talk about fiat currencies or the paper money, which you can send it to one guy, but you at the same time you cannot send that to another guy. But in digital currencies, it's like a digital file. You can make a copy of it. So for example, you have a file saved locally to your computer. You can easily copy it from one file location to another file location. So similarly, in digital money or digital currencies, it was possible to send the same money to two different people at the same time, causing the double spending problem. So let's say I have 50 Bitcoins and I want to send it to two people at the same time. So can I do that? Yes, I can do that because it's a digital footprint, digital asset. So it is possible to do that. But in blockchain system, it is not possible at all. And I will tell you why. Because if we send the digital asset to a person in one transaction, and suppose that transaction is now unconfirmed transaction, which goes to a transaction pool. Now, if I send this same Bitcoin twice and it goes into another transaction pool, now the blockchain system will work in such a way that blocks will be created and they will be confirmed. So if one block is confirmed and the second block which has this second transaction is not confirmed, it will be ignored. So in this sense, double spending problem was resolved using blockchain. Satoshi Nakamoto is a person or a group of persons, it is not known, but it's an anonymous identity who created Bitcoin. So he wrote an academic paper called Peer-to-Peer Cash System in 2009. And in that paper, he wrote how a digital cryptocurrency can be created without relying on third parties and having a consensus in a distributed network. So he created this cryptocurrency called as Bitcoin, and he implemented that. And we now know how popular Bitcoin is. And then after Bitcoin became popular, the online black market Silk Road was created, and it was first modern darknet market. It was a platform for selling drugs to guns. And as part of this dark web, the anonymous proxies like Tor were used so that people can buy anything anonymously without any monitoring. So in October 2013, FBI busted the website owner and arrested him, and it was shut down. And in 2013, Silk Road 2.0 and other version of the online black market, it came up, but it was also discovered and closed down. So let's look at the timeline and trend of Bitcoin. So we observed that Bitcoin has been gaining popularity since it was first implemented in 2008, where the first block was created in 2009, and then it went open source, and a Bitcoin developer community was created. People started joining as Bitcoin developer. They started working on the protocols of Bitcoin and started improving it. And then Bitcoin exchanges were created, and people started using Bitcoin in a cryptocurrency wallet, and they started trading Bitcoin as well. And several companies also formed a consortium to understand and implement the blockchain. So the blockchain was an underlying concept of Bitcoin, but people started realizing that this can also be used in other applications. So they started working on ICOs and implementation of POC concepts. So we have been seeing that blockchain as a concept itself and technology itself has been gaining a lot of popularity since years. And by looking at the investment in the blockchain by industry, we know that financial services are the domain where it is heavily invested. It's invested in real estate market, banking or financial institutions or trading platforms. And after that, we can see that healthcare, hospitality is also using blockchain as a technology. At this point of time, these industries, they are trying to experiment whether this technology can fit into their business. It can align with their business. So they are developing proof of concepts, and they will see that if it will work, then it will be adopted across several domains. So let's understand the concept of distributed ledgers. So blockchain is one type of a distributed ledger, and distributed ledgers use independent computers. So we know what a ledger is. So a ledger keeps a track of the transactions. It's like a bookkeeping where you have the transactions, the person who made that transaction, what was the money amount that was sent in that transaction, and what was the balance that left in that transaction. So distributed ledgers use independent computers to record, share, and synchronize transactions. It's a digital system for recording the transaction in which the transactions and their details are recorded at multiple places at the same time, and there is no central authority. This distributed ledger technology, called as DLT, could fundamentally change the financial sector, making it more efficient, resilient, and reliable. The groundbreaking feature of this distributed ledger technology is that ledger is not minted by any central authority, and updates to these ledgers are independently constructed and recorded. So you can see in this picture that in centralized payment systems, there is a central controlling authority, a central bank, and there are some small banks which are controlled or regulated by the central bank, and the consumers take the services from those banks. But in blockchain's distributed ledger system, there is no central authority, and it uses a peer-to-peer network where there are several parties that are involved, and they maintain same copy of ledger at each node or each party. In that way, these ledgers are distributed geographically. It does not remain like in a central payment system at one place, like in a central bank. So every entity who is involved in the distributed ledger keeps a copy of the same ledger, and control is not there with one single authority. So there has to be one consensus that has to be agreed upon before transactions can happen. So let's look at the blockchain technology itself. What exactly is blockchain? So blockchain is a continuously growing linked list type analogical records. These are called blocks, and these are linked using cryptography. So it looks like a linked list itself, where you have a chain of these blocks which are joined together, and each block contains a record or transactions. Now the characteristics of a blockchain is that it is anonymous. So anonymous in that sense that there is no identity of a person who is making any transaction. So it is anonymous, but it is not as anonymous because it is possible to identify that some money has been sent from one party to another, but anonymous in that sense that there is no mapping of that identity to a real person. Decentralized means it uses a decentralized distributed ledger system where there is no centralized authority or control. Consensus means a common agreement between different nodes or the parties who are involved in the transaction that they have to abide to before making any transaction. So this is a general rule of considering a block or before creating a blockchain. Transparent in that sense that all the blockchain transactions are visible to every node, or you can say that you can see all the transactions happening in those ledgers. If you want to download this blockchain ledger, you can see what transactions has happened since the first block was generated. So you can see all the details, but you cannot make out the real identity of a person, but just you can see the addresses which are involved in the transaction, what is the amount of the transaction that happened. And this blockchain is very fast in transactions. It's like in few seconds to minutes the transaction happens, but in normal banking systems it might take few hours to days for moving money across the borders. So that is why it is considered to be an amazing technology where banks are looking to consider it for implementation. Immutable. This means that blockchain, whatever blocks or transactions that have been recorded in those blocks cannot be altered or modified once written. So this is because of the hashing and cryptography technologies that are involved in the blockchain. And there is no possibility that the transactions can be manipulated without identification that a tamper has been done. But it is not possible at all theoretically, because the other nodes or the parties who are involved in the transactions, they will ignore that because of the consensus. And non-reputable means because it involves use of digital signatures, the sender cannot deny that it has not sent any transaction. So we are able to prove, because of the digital signatures that are involved, that a person owns a number of bitcoins or tokens, and they have sent those to another party in the blockchain transaction. So blockchain is this basic underlying technology of not only Bitcoin but other altcoins or blockchains like Ethereum or other alternative currencies like Bitcoin Cash, Litecoin, etc. So there are three basic types of blockchains. One is public, private, and then hybrid. I would say that there are two types of blockchains, as in categories. One is permissioned and one is permissionless. So permissionless is the public blockchain and permissioned is the private or the hybrid blockchain. So in permissionless blockchain, permission is not required by the nodes or the participants to write, read, or send transactions. And anybody can join that blockchain, and there is no central authority that we have to seek permission for. And in private blockchain, permissions are required because that is created by an organization for its private use. So we have to take a permission to read or have consensus. In the private blockchain, there is a category of that private blockchain called as hybrid blockchain, where consensus is defined to a particular set of nodes. So suppose there is an organization called R3, which has created a consortium where only a certain number of banks have come together to create this consortium of blockchain where they can use this blockchain for their own purposes. So only those banks have access to that permissions that are defined in that consortium blockchain. So let's look at the components of the blockchain. So the components are ledger. So ledger actually contains the current world state of the ledger, the current transactions that happens. So it records everything, what transaction has happened from which party and what time. So it's like bookkeeping. Consensus network is a collection of network data and processing peers forming a blockchain network. So it's like a protocol that every party who joins that blockchain network has to agree to. And this protocol is responsible for maintaining a consistently replicated ledger. So all the parties, they achieve a consensus in maintaining a particular state of the ledger. Membership is a component that manages the identity and transaction certificates, and events creates notifications that happens in the operations of blockchain. Systems management is a central component that provides the ability to create, change, and monitor the other blockchain components. And wallets, we all know that wallets are used for transaction of bitcoins. As such, I mean, wallets can be for other blockchains as well, but in regards to Bitcoin, these are places where you can store your bitcoins and you can spend them using your private key. And the address to which you want to receive the bitcoin is your public key or the bitcoin address itself. So let's take a look at the mechanics of instructions, how the blockchain works, and what constitutes actually the transactions. So the transaction is composed by inputs and outputs. So each transaction, if you want to consider, it consists of an input and an output. So input means who has sent you that Bitcoin. So it means that from where the money came, and output means where the money is sent. So there is a concept called UTXO, which means that unspent transaction outputs, which is used in the blockchain for fundamental building of the block transaction. So suppose if there is a party called Alice and she wants to send money to Bob, then the money that is provided to Bob is actually an input that comes from the Alice, and the money then reaches Bob, and he actually owns that Bitcoin, and that is called output. Now output actually means then the number of Bitcoins that is available for the Bob to spend. So let me give you an example. In this diagram you can see that 10 Bitcoins are sent as an input for a transaction. Now it means that 10 Bitcoins are available for that transaction, and that can be spent. So if I suppose say spend this 10 Bitcoins completely, then there is no UTXO because the transaction has been spent. It's not unspent. But in case if I spend only 4 Bitcoins and I don't send any Bitcoin here to another party, this 6 Bitcoin actually becomes a change for my transaction and it comes back to me as an output. But in unspent transaction outputs, we have to spend all the Bitcoins as part of that transaction output. So in this diagram, you can see that if I have 10 Bitcoins, which comes as an input because it comes from a previous transaction, and outputs are the amount of Bitcoins that I have available to spend. So I can send 4 Bitcoin to another party, which constitutes another transaction, and 6 Bitcoins to another party, which is a separate transaction. Now in this, you can see that these 4 and 6 Bitcoins are constituted as inputs for those transactions. So it means that it's an address where you can receive Bitcoins. And when you send these Bitcoins via output, it means the address to which you are sending these Bitcoins. So now at this end, you can see that all the Bitcoins that you have received up to the last node TX3 and TX6, but you are not spending any further Bitcoin. You have all those 6 and 4 Bitcoins with you, but you are not spending them. So those are called unspent transaction outputs. So in blockchain, to have the transaction work, you have to spend all the unspent transaction outputs. So you can see in this below diagram that there is a digital signature which is being used to create those transactions. So now you know that the transaction actually is input and output. Now those transaction, for an input, it consists of address from where the money came from, and the amount of the Bitcoin that you have, and the address to which this money is going to. So that means a transaction structure. Now this transaction has to be created and sent into the blockchain network. So for that, this transaction is sent by the creator to a number of nodes called peers. So these peers can do 3 things. They can verify whether this is a valid transaction, and they can check whether the balance or the amount that you have spent actually you have ownership to, or you have that many number of Bitcoins available with you, and then update the ledger with the entries of the amount spent and unspent in that transaction. So once you do that, these all blockchain peers, they validate these transactions and create those transactions into blocks. So we'll look into further how it works out. So the two underlying technologies of blockchain are hashing and digital signatures. So we all know what hashing is. So hashing is basically a mathematical function where you create a hash of any data of arbitrary length and convert this into a fixed length hash called digest. So we know that hashing is a one-way function. So suppose if there is a function x equal to hash, there is no way that this hash, if known, can be reversed back to the actual content. So we are not able to derive the value of the content from the hash. So it's a one-way hash. So it guarantees that there is no tampering. So suppose if you send a file to someone over a network, and with that file you provide a hash of that file, and the other party who receives that file, if they match the hash of the file which is received with the hash that you have provided, it means the file has been sent as it is and there has been no tampering. So there is no modification that was done over the network. So this guarantees the integrity of the file. So in blockchain, the hash of the whole blockchain, if you take, it determines a world state. So it means that whatever state of the ledger that you have at one peer should be same at all peers that are involved in the blockchain system. Another technology that is used as part of the cryptography in blockchain is called digital signatures. So digital signatures, we know how digital signatures work. So when you have a document or data, and when you click sign using a signature function to call the hash, to create a digital footprint called a hash, and then you generate a pair of keys called as public key and private key. So private key is the key that you have with yourself, and public key is the key that you can distribute it over the internet to the other party whom you are communicating to, so that they can verify whether the file that you have received is valid and it came from a trusted party or not. So in blockchain also, what happens is that a sender generates a public key and private key. So public key, it resembles the address of the recipient, and private key is the public key is basically the address of the party who is sending the transaction, not the other party who is receiving the transaction. So suppose Alice is sending this money to some other party, then public key is the actual address of the Alice wallet, and private key is some kind of a password where it can be used to send that money. So if you don't have a private key in your wallet, you will not be able to create a transaction or send money to some other party. So in digital signatures, the private key is used in the signing algorithm to create a signature. And you can see in this picture, this transaction consists of a sender address, which is Alice's address, and this recipient address and the value which you are sending to. This is a transaction. You create a hash of the transaction and you feed it into a signing algorithm and combine your private key and send it over as a signature. And with that signature, you also combine your public key and the transaction itself, which is the actual document that I told in the earlier example. So when these three things reach to the other party, they use a digital signature verification algorithm where they verify that this file that you have received is actually the one which was sent by you. So in that case, the public key is used to decrypt the hash from the signature, and the actual file or document or transaction is hashed again to match the hash which came from the signature. So if the hashes match, it means that the file that was sent is not tampered with, and also it came from Alice, not by any other party, because Alice is the owner of this public key and private key. So only Alice can have that private key which she used to sign the document or transaction. So we'll talk about Merkel trees. So Merkel trees are a very important concept in the blockchain, and many people are not familiar with it. So Merkel tree is like a binary hash tree, which involves taking large amounts of data and making it more manageable to process. So in our case, we will see in a picture how the Merkel tree is created. So it's like a tree structure in which each leaf node is a hash of block of data. So you can see that there are transactions at the bottom, transaction 1, 2, 3, and 4. So each transaction is hashed to create a leaf node. So hash transaction 1 is the hash of this transaction 1, and hash of transaction 2 is the hash of this transaction, and so on. So these are the leaf nodes. These leaf nodes are again hashed to create a parent node, which is the hash of these two transactions. So it happens on the both sides of this Merkel tree, because it has a branching factor of 2, and each node can has to a maximum of 2 children. So suppose if there is no children in this branch, on it has only transaction 4, then what happens is that in the system of Merkel tree, this transaction is duplicated on the other side, and then these transactions are again hashed to create a parent node hash. And all these parent node hashes are again hashed together to create a Merkel hash or Merkel root. So in a way, it summarizes the whole transactions that had happened underneath. So you can see in this diagram that all these blocks as part of this blockchain, they are combined together via a reference pointer. So each block references a node from the previous block. So in that case, you can see that transaction root or the Merkel tree is a part of each block. And then there is the previous hash which is used in each block. So in this case, if there is a modification in any of this transaction, suppose if the transaction 3 is modified or altered by some attacker, the hash of this transaction would change by changing the hash of the parent node and changing the hash of the transaction root node or the Merkel root itself. So if the Merkel root hash changes, the hash of the whole block changes. And this is the previous hash. So all the blocks that comes after it also changes, because the block hash has also changed. So in that way, if there is a little modification within any transaction, it is easily identified by the Merkel tree. So simple verification, payment verification, SPV, is a method to verify the transaction. So what happens in SPV protocol is that instead of downloading the whole blockchain, you just have to download only the block headers that contain this Merkel root, previous hash, nouns, etc. So it is very easy to identify that a transaction actually is in the block by verifying the Merkel root of that transaction. So this is a way to identify whether a particular transaction exists in a block or not. Now we will see that what actually constitutes a block header. So a block header contains a version. So version would be the software version of the blockchain that is being used, and pointer to a previous block is a reference pointer to the previous block hash. The Merkel root, which I just explained to you, the timestamp. So timestamp is a time where this block was actually created. Difficulty level is a target level that is defined by the Bitcoin or the blockchain system, where the block creation actually has to match the difficulty level. Nouns is a interesting number. So all the miners who are involved in the blockchain transaction, they are just trying to find the value of the nouns. So I'll show you how it happens. And then consensus algorithm, which is a proof of work mathematical puzzle that all these miners try to solve by identifying the value of nouns. And we see that in the Bitcoin blockchain, SHA-256 hash is being used. And it's not a single operation of hashing of SHA-256 algorithm. It's a double SHA-256 hash that has to be calculated against the block header. And we have to find a value of nonce such that if we put it into the equation of hashing, it has to meet a threshold level or a difficulty level. And once it meets the difficulty level, the block is said to be valid. And this difficulty level is decided by the protocol, and it's automatically readjusted during the mining operation. So suppose if a block is discovered and created and it was found to be valid, and it took very less amount of time for the miners to do that, the protocol itself readjusts this difficulty so that the block creation time increases. And suppose it takes too much time, then difficulty is lowered. So it maintains an equilibrium by the protocol of the blockchain. Now we will see this example if we modify any transaction, how it affects the whole Merkel root. So suppose in this you can see that we modified one transaction and it resulted in change of hash for the parent root, and then again it changed the hash of the Merkel root. But what if we have to validate whether a particular transaction is there in the blockchain or not? So Merkel tree is actually not used to search for a transaction, but it is used for verifying whether a particular transaction is in the block or not. So whatever transactions that go into the block, they are unalterable and they are immutable. So they go into the blockchain as a permanent entry. But if someone asks that, show me the proof that this transaction is existing in that particular block, then we have to show a proof called a Merkel proof. So suppose in this picture, you can see these all transactions have been hashed. And now we have to show that this hash HD exists in that Merkel tree or not. So for that, we need to know only 3 transaction hashes. One is HC, HAB, and HEFGH. So if I already have this transaction, I can create the hash of this transaction HD, and if I am being aware or if I'm provided the hash of HC, I can create the hash of this parent node HCD. So after that, if we are also provided the hash of this parent node HAB, then combining with the hash that we calculated, we can combine and create a hash and find another hash of the parent node HABCD. Now we are also provided the hash of HEFGH, which is also the hash of this parent node. And once we combine these together, because we have the hashes available now for both of them, we can find the hash of the Merkel root. So in this way, we will be able to identify that yes, the Merkel root is correct, and this transaction actually exists in the block. So if anything changes, the Merkel root changes, and we verify that this Merkel root does not exist in the block, or there is a tampering that has been done. So we will look at what happens in the block header. So we have this block, and this block constitutes of two parts. One is block header and the body of the block itself. The body of the block contains the transactions, actual transactions, but the block header, it only consists of few things like the version, which is the software version being used in the blockchain, hash of the previous block. So hash of the previous block is the block hash that was created by the previous block. So it is included so that it makes up a chain, and if value changes, the whole hashes of the previous blocks has to be changed as well. So this is very important. And the root of the hash of the transaction means the Merkel root. Timestamp is the block creation timestamp, the difficulty level, and the nonce. So nonce is the very important feature here in the blockchain mining or the block creation. So what happens in this, the hash of this block header is calculated in such a way that each miner has to find a value of this nonce, which is a random number of 32 bits that each miner has to find out in order to create a hash of this block header such that it meets some threshold limit, which is the difficulty level. So if I find, suppose, a number, say 34 as a nonce, and calculate or combine these things as part of this block header and calculate the hash of the block header itself, my block hash should match or should be below this threshold. So threshold is like a Bitcoin like address, but it is actually not Bitcoin address, it's a hash. And it is a hash which has a difficulty level. So difficulty level could be something like the hash that should be created for the block header should have 4 leading zeros. So it can have 3 leading zeros, 4 leading zeros, 5 leading zeros, etc. So this is the difficulty level that the block hash that has to be created should be having a certain leading zeros in the hash itself. And that is not very easy to compute. So miners actually try to solve this puzzle by solving the hash for each random 32-bit number. It could be starting from 1 to whatever number they compute. And this nonce has to be set only once for calculation of the block header. So for each number, this whole block header hash will be calculated and matched against the difficulty level. Now let's take a look at how the block creation happens. So we will see that these blocks are joined together using the hash pointers from the previous blocks. And there are certain times when at the same point of time, 2 or more blocks are declared as valid. So in this case, what happens is, suppose if there are 2 nodes or miners who have received a number of transactions, and they have collected those transactions from the memory pool that they have, and they have both solved the proof of work puzzle, and now they had distributed these blocks to the other nodes. And other nodes, when they receive these two blocks, both of these blocks are valid because they have gone through this mathematical proof of work puzzle. Now they are both joined as part of the blockchain, so both are valid. But now this is a fork situation, that which is the real blockchain, which is blockchain that we should follow. So what happens is that miners keep adding blocks to these chains, both the chains, and ultimately there will be a point of time that one chain will be longer than the other. So like 6 blocks are created, and during this 6 block creation there is a very little possibility that both of these chains will keep on growing. So there will be one chain that will be longer at a particular point of time, and as per the rule of the blockchain or the Bitcoin blockchain that we are talking about here, the longest chain will be supported and the other chain will be ignored. So it will be called as abandoned block or orphan block. So the transactions that are in this orphan blocks, they again go back to the memory pool, and they can be collected again by the miners, so that they can be collected as part of another block. So we'll see how the Bitcoin blockchain workflow works. So we will see that there is a sender, Pam, who wants to pay Martin some Bitcoins, and he has a wallet where he stores these Bitcoins and he was to send it to Martin. Now what happens is that he uses the Martin's address and he sends these Bitcoins via a private key, because private key is the password that he has in his wallet to spend those Bitcoins, and he sends that with a public key which is known to everybody. Now this transaction is relayed on a peer-to-peer network where there are too many parties which are called nodes, which may be a normal node or a full node. Full node actually means a miner who want to incentivize himself by creating and validating a block in order to get some reward. So all these miners who are connected by a peer-to-peer network, they receive these transactions by PAM, which is broadcasted to all these miners, and each miner, he or she has a software running on his machine to download the blockchain on their system, and these transactions are now signed with the private key, so they can be verified by these miners using the public key of PAM. In order to verify this, the digital signature is being used for verification, which I showed in the earlier example. And then after matching the hash of the transaction which was sent by PAM, it is confirmed that these transactions are valid. Now these transactions actually rely on a data structure called as memory pool, where these are called unconfirmed transactions, and these transactions at certain point of time by each miner, they are collected and created into a block called as candidate block. So it's not the final block, it's just a candidate block that they collect all these transactions into. Now it's like a voting process for each miner to contribute some processing power via a proof of work mathematical puzzle. And after solving this puzzle, which I just showed you in the earlier example, that they have to calculate a hash using the nonce. And once they calculate the hash which meets the difficulty level, the block is said to be a valid block. So they have solved that mathematical puzzle. So after solving that block, they relay or broadcast those blocks to again the miners, and these miners, they verify that the block is valid and contains the Merkel root. And once they mark it as valid, they the blockchain system actually rewards the miner with some bitcoins. And then this block is then joined with the existing blockchain. So in this way, the blockchain is created, and upon confirmation of a minimum number of blocks, suppose in Bitcoin it happens with 6 block creation, that a transaction is confirmed, and then this money actually reaches Pam's wallet, Martin's wallet. So we'll just touch a brief on what are the attacks on the blockchain. So the attacks on the blockchain infrastructure are mostly known to be theoretical or old attacks that have been fixed in the blockchain protocol. They are not there anymore, but there is a possibility that these attacks can take place because they are valid in theory, not in practice. So there is a 51% attack which is widely known, and it's one of the biggest attack, because in 51% attack, the attacker gets a majority on the network. So in a 51% attack means a bad guy is getting as much computing power as the entire rest of the Bitcoin network combined. So if a miner, which is an attacker, gets a 51% of hashing power of the Bitcoin network, he can control the whole network. He can create the transactions and double spend, and he becomes a majority of the network. So what happens is that multiple mining pools, they can join together to contribute their hashing power, and they can become a 51% of the network. But then there was one situation in which mining pools, they came together, and they were at the brink of getting 51% of hashing power, but then they decided to step down because they realized that it is more beneficial to achieve mining and get transaction fees rather than doing the double spending. So another attack is called as Sybil attack. So in Sybil attack, what happens is that in a peer-to-peer network, an attacker can create a situation of creating multiple identities or false or fraudulent nodes, and these fraudulent nodes are remained in the attacker's control, and the other honest nodes will connect to these fraudulent nodes. So in that way, the block it will block the transactions, the real transactions that happen. They will disconnect you from the public network and connect to their fraudulent network, and they are in the control then to validate the transaction, which transaction will go, which blocks will be created. Another attack is called selfish mining attack, which is an attack on the integrity of the Bitcoin. So this is a situation where there is one miner and he creates this block, but he does not publish the block to the other miners. So he does not distribute the valid solution to the network. So selfish miner then continues to mine the next block and the next block and so on, maintaining its lead over others who are also trying to solve the blocks. When the rest of the network is about to catch up with this selfish miner will then release the solved blocks into the network, and it will claim the most majority of the block rewards. So this is a very unfair situation, but selfish mining is possible because is there a flaw in the proof of work algorithm, which is the consensus algorithm. So other attacks could be DDoS attacks on the infrastructure of the blockchain. So there are like multiple requests can be sent, a large number of requests can be sent by an attacker, and they can try to clog the node memory or block you from transactions. And then there are attacks on the cryptography implementation on the blockchain. So there have been instances when a group of supercomputers have been involved in trying to break the cryptography involved in the blockchain itself. But so far there has been no success that has been known to us, but it is possible that in other kind of blockchains, not the Bitcoin, other blockchains, depending upon the type of cryptography being used, this attack can be very real. Other attacks that have been in existence these days is crypto mining or crypto jacking attacks, where attackers try to create a plugin or trick you into installing some malware on your machine, which actually installs in the browser of your machine, and they try to use the computing resources of your machine to mine the Bitcoins. So let's take a look at the use cases and applications of blockchain. So blockchain is now in the research phase. We cannot say that it is a foolproof technology. I mean, the Bitcoin has been successful, but now we have seen that there are alternative versions of Bitcoin itself, which are more reliable, like Ethereum. And major companies are now researching in this domain. Apart from the cryptocurrency usage itself, the startups have come up with their products and solutions, and just like initial public offerings, they have created initial coin offerings where they ask you to invest in their companies, where they will give you some stake in their system or product. And these smart contracts are programmable codes that rely, or they are embedded in your blockchain. These are just like normal contracts, but they get automatically executed when there is a condition that is met or a criteria that is met. So it's more like a if then that condition. So if this happens, then this will happen. So it's like a analogy to a coffee vending machine. If you enter a coin, you will get coffee. So this is a situation that it has to trigger upon a certain condition. If it is met, then the contract will be automatically executed, and it will not rely on third parties for contract execution. So there has been issues in the scaling and performance of blockchains, Bitcoins also as such. So Lightning Network and scaling improvements have been going on. And these blockchain applications are into different domains like financial markets, insurance, regulations. So we have heard of this term called fintech. So fintech is a revolutionizing technology that is making use of all this digital innovative emerging technologies, including the blockchain. So blockchain is really making a foray into that. And there are other non-financial domains where blockchain also has application like healthcare, IoT, data storage, social media, gaming, and other infrastructure related domains. So with that, we finish up with our blockchain session. Now we are open to questions, and will are ready to answer your queries.
Send you the question over the chat.
So are there any compliance involved for crypto requirements? So the question is regarding, are there any compliance or regulatory requirements in the crypto domain? So as of now, the crypto domain is not regulated. If you take an example of Bitcoin as such, Bitcoin is not regulated by any country as such. They have just banned these cryptocurrencies which are being used for money laundering or terrorist financing. But there has been no regulations in this domain which are globally available, so that every country can abide to, saying that the Bitcoin implementation or blockchain implementation should be in this particular domain implemented in particular way. So there are no compliance and regulations as of now. But now banks, if they are considering to regulate this, they have to first adopt this and adapt this, that Bitcoin is a legal tender or a cryptocurrency. So, but for now it's not. But there might be a situation in future where these crypto tokens or the blockchain as a technology itself can be regulated for security and privacy purposes. So why government is considering the mining as a illegal activity? So now, to answer this question, I would say that the mining of the cryptocurrencies is your personal wish that you want to do without involving any authority. So you are trying to use this anonymous valid system where nobody is able to see what transactions have been done, and you can use this anonymous identity to create your own wallet and convert all your fiat or black money into digital cryptocurrency and send it over to any criminal. So in that way, in anti-money laundering and terrorist financing has been happening a lot, and we have seen that ransomware attacks are also being launched, where Bitcoin is accepted as a ransom amount. So in that case, governments are law enforcement agencies think it is as a threat to the national security also. That is why it is considered as illegal, and a lot of countries are banning the cryptocurrencies. They are saying that we are not accepting it as a legal tender, and some of them are trying to monitor the actual bank accounts to see whether people are buying cryptocurrencies online using their bank accounts and how much they are buying, and trying to evade taxes. Hope that answers your question. So blockchain forensics, this is another question that has come up. So blockchain forensics is another domain. But now, since blockchain is emerging technology, we have to say about some blockchain which is already predominantly being used, which is like Bitcoin. So in Bitcoin forensics, we already have this ledger available. So you can see a lot of blockchain explorers where you can explore the whole content of the blockchain. You can see all the transactions. But in the offline wallets, the nodes or the software that you install as part of the blockchain, you can do a forensics. You can find out the blocks that are downloaded, the blockchain database that is downloaded onto your machine. You can find out if there is a possibility to find out the private keys and how they are stored on your machines. So forensics is another domain. Yeah, definitely it is there in the Bitcoin or blockchain domain. So the question is, how is the ledger digital identities are maintained? So ledger digital identities are maintained using the block identifiers. So each block contains a set of transactions, and each block has a unique identifier itself. So that is not part of the block header, but it is used as part of the block itself to identify at what time which block number was created. And you can also use a website called blockchain.info to go through the ledgers that are created, the blocks that are created, and the ledger of Bitcoin. And you can see all the transactions, Merkel root, timestamp, hashes that are created, and also the Bitcoin addresses, the receiver and sender addresses, and the amount of Bitcoin that has been sent. It will be very clear to you that there are block numbers also that are assigned, and what time that block is created, with what size, and how many number of blocks have been created yet. So this is a very interesting site, blockchain.info. And you can also look at other blockchain explorers, which are widely available, who read the blockchain ledgers and give you a complete detail about the blocks that are created, the transactions that have happened. But we cannot tag the digital identities of the sender and receivers, because those are just hashes. So in that sense, it is very anonymous. But there are wallets like Coinbase. They verify your identity and they know about your public and private keys. So public key is basically your address. So if they have to share this information with law enforcement, they can very well do that. So if there are no more questions, we can finish. And you can drop your comments. And if you have any more questions, you can send at info@infosectrain.com, and we'll reply you on that. So thank you
Hi,
everyone for attending the.
hi everyone. Thank you so much for your participation in this webinar. And soon we will be back with more interesting topics. And it was a pleasure to have all of you guys. Thank you so much from Team InfosecTrain.
Thank you. It was useful. Thanks so much.
Thank you so much, Rakesh and InfosecTrain.